Hi everybody, welcome to this introduction to linked lists. We're going to look at Java's linked list class. A linked list is an abstract data type. Remember, an abstract data type is a data type which stores data and also has methods to help us process that data. So we're going to have a look at some of the methods of the linked list data type in Java in this tutorial. We're going to look at a scenario where we've got 5 hoppers racing towards a target distance, and the first hopper to make that distance is the winner. However, as they're racing, they will randomly trip up from time to time, which will no doubt slow them down. So before we get into the video, you want to make sure that you've taken some time to look at the hopper class. Every hopper has a name. Every hopper knows its hop distance, its current hop distance during the race, and every hopper tracks the number of times that it has tripped up. Okay, so that's all managed in the hopper class. And you need to take a little bit of time to look at the race program itself before you continue watching the video. Fully recommended. Okay, if you've had a chance to look at the code, let's get into the core of the video. Now, basically, the main function initializes the hoppers. Hoppers, by the way, at the moment is a global variable. It's just a standard static array of hopper objects. Okay, and when we initialize the hoppers, we basically set the length of the array to 5, and then we populate the array with hopper objects. The issue with using a static array is that once we declare it and initialize it, we can't change the length of the array. However, for this problem, it's fine, because the race will always have 5 hopper objects. Next, in our main program, we set up the target distance, then we start the race towards that target distance, and when the race is finished, we grab the index of the winner. Okay, and we use that to display the results table. Okay. Now, I'm not going to talk you through all of the code. As I said earlier, I hope you've had a chance to look at the code and try and figure out how this program works. What I want to turn your attention to is this method here, check trip count, which is used in, where is it used? It's used in the race function. When we race, we allow all of the hoppers to hop, then we check the trip count of each hopper, and if the trip count is above a certain value, then that hopper will be removed from the race. And then we see if anybody's won yet, and if that's -1, then we'll just continue racing until we get a valid win index, which we return back to the main program. But let's go back to the check trip count function. Now, what I could do to remove a hopper from the race is set the hopper reference variable to null in the array. But if I do that in this scenario, I'm going to have to go back into all my other methods and look for examples of code where we're processing a hopper object. For example, hoppersI.getName. If hoppersI is null, then my program will crash because null doesn't have a getName method. Okay, so what I'm going to have to do now is go into my other methods and see if I can figure out how to stop my program from crashing. If hoppersI doesn't equal null, then I'm going to do this system.out.print. Okay, so that's a little bit annoying to have to go and make those changes. One strategy to avoid having to deal with null is to use a linked list. So let's look at how to use a linked list in Java. So instead of declaring my global variable as a hopper array, I'm going to do this instead. Let's just comment that out. I'm going to say, okay, my new global variable is going to be a linked list of hopper objects called hoppers. Now, I'm going to get an error here because I need to import the linked list library file into my program. Library files are great. They're full of code that we can use in our program. It's already been pre-tested, so this is just great. I can use the linked list class in my program. Now, when I initialize the hoppers, what I want to do now is initialize the linked list. So hoppers is a new linked list of hopper objects. Okay, and I'm going to add these 5 hoppers to the linked list using one of the linked list class methods. Okay, so we're going to add Fred to the linked list, and we're going to add, ooh, look at these add methods. We've got this add first method. So I can put Dave as the first hopper in the list. Okay? And let's put, oh, let's choose another method for adding. Let's just have a look at another one. There's this add last method. So we can put Cheryl in as the last hopper in the list. And if you think about it, this is allowing us to mimic stack behavior or queue behavior. This is really the same as push or enqueue. Okay, so we can implement stacks and queues using linked lists. That's an important point. Okay. Now for this program, it doesn't really matter which of these methods I'm choosing to use, because I don't really care about the order, as long as Lynn, Cheryl, Sam, Dave, and Fred are populated into my linked list. Okay, so let's just do that. And the last one is Sam. And let's just remove all of these original hopper. There we go! We've just populated our abstract data type hoppers with hopper objects using the linked list class methods. Okay, so initialize hoppers has been updated to handle linked list behavior. We're now going to look at the race class and see if we need to make any changes in the race class. So in the race class, whoa, we don't need to do anything. Everything's fine. But let's first go and look in the hop class and see if we need to make any changes. Yes, hoppers is a linked list. So we're going to use the linked list class's size method. That really tells us the length of the list. Any other changes? Yep, hoppers I in linked list programming, we change that to be get I. Okay, so hoppers.getI is a hopper object in the linked list. Okay, and we're going to do that here. So get is another linked list method, and we've got to do it here. So that's the hop updated. Then the check trip count, I don't think we've programmed that yet. Check trip count is waiting to be programmed. That's everything done. Then we go back up to main, that's finished. Now we go into the results table. Oh, wait a minute, we need to check the win as well, don't we? In the race, after we do the hopping and the check trip count, we also do check win. So let's go into the check win method and see if there are any. Yes, so it's that .getI issue again. So I'm just going to copy that. We'll just paste it in there. And we'll paste it in there. And we need to change the length to size because we're dealing with linked lists. All right, okay. And then after we've done that, we go into our results table. Oh yeah, we update the trip count as well. So that should be .getW, .size, .getW, or .geti. .geti. And .geti. Okay, so we're updating our program to be able to handle linked lists. And now finally we want to go to the results table. Where is the results table? That's what we've just finished that. Okay, we're done. Now then, let's turn our attention to the trip count. We need to remove a hopper from the race. So let's do that. For int I equals 0, I is less than hoppers dot size I++. We're going to loop through the list. If hoppers I... Oh, no, we're not using arrays anymore. We're using linked lists dot get I dot get numtrips is greater than 320. If that's true, we're going to remove the hopper from the linked list. How do we do this? Yeah. We're not processing a hopper this time. We're processing the list, which is hoppers. Hoppers dot remove. There it is. Remove the hopper at index I. All right, I think that's it, guys. Whoa. So a couple of things that we need to understand here is a linked list is an abstract data type which stores data and has methods which allow us to process the data, such as the get method, the add first, add last methods. Also, we can remove elements from a list very easily using the remove method. That will change the size of the linked list. So when we add elements to a linked list, the linked list is growing in size. And when we remove elements from a linked list, the linked list is shrinking in size. Okay? So a linked list is a dynamic data structure, not a static data structure like an array. So let's run the program and see if we can get it working. Yay! Okay. So 5 frogs started the race. Whoa, there was lots of tripping going on. Oh my goodness. Only 2 frogs finished the race. And Lynn is the winner. 3 frogs were eliminated because their number of trips was greater than 320. Let's run the program again. Whoa! Only 1 frog finished the race. Incredible. All right, guys, there's an introduction to linked lists using the Java linked list class.